My name is Francis Smith. I'm a student here at BATC in the Controls Engineering certificate. I work industrial maintenance part-time as well.
So my name is Emily Briggs, and I've been a student here at BITC for since the beginning of 2015, and I'm working on controls engineering and robotics. I've been enjoying learning a lot of new things. Okay. Yeah, go ahead. Introduce.
So our project is a robotic vending machine. The HMI is used to select which product you want, which sends the information to the PLC, which stores that information and tells the robot which job to run. The robot has 4 jobs in it in a single user frame. It grabs the appropriate candy, places it on the conveyor. The vision system takes a photo of what's there, compares it against a learned job that we've created, and if it is correct, it'll convey the product out. If it's not correct, it'll reject the part. Yeah, that's it.
All right, so let's start with the HMI screen. We wanted to make it look nice, and it's obvious what it does. We have some good logos here. We've got, you just choose a job here. We also have a background screen that we've got. This top graph is going to keep track of the current count. Each time you select a job, the number of that product is decremented in the PLC, so it will it'll count down so you don't run out, and it will count up here so that you can monitor how many of each product has been chosen. You can see which one's the more popular. When we start running low, then we can choose here. I can manually enter the correct number that there is if we stuff them in there. Manually enter the correct number, and then the restock job will let it know that we have entered more in there. And that has to do with the robot program. And I'll talk about that in a second. If there is a fault, then a screen pops up in front. Very simple. It says there has been a fault, and it has one button on it, and you push that button to reset the fault. So nobody's going to get confused.
Okay. So I'm going to talk about the PLC here. The PLC communicates with the robot over Ethernet. We had a few problems with that initially. I had never done that before. I'd never hooked a PLC up to a robot, and it took a lot of work. But that was the big challenge of getting this all to work. We were almost tempted just to use normal inputs and outputs onto the controller, but we eventually got that Ethernet working, and that turned out to be great for us because it limits the amount of wiring that we have between the robot and the PLC, and it gives us unlimited distance. We can control it from pretty much anywhere. It also gives us many more IOs, so that we don't have to, we're limited on the actual IO on the back of the robot, and this gives us the ability to do a lot more with the robot. It also allows us to share sensors. We've got our light curtain. We've got an end conveyor sensor, a start conveyor sensor. We've got the vision camera, and we've got an end effector sensor that tells us not to move anymore if it reaches the product. The PLC also operates the running light and the conveyor. It chooses which direction to go and how long to go in that direction.
So now we'll talk about the robot job. To start, the robot was I set up a user frame. The user frame is aligned with this tray, which, by the way, Francis welded the tray and this here, the stand for the camera. So what that means is that the robot is much easier. It's much easier to have the robot move in alignment with that. with the pick fixture. When you choose a job, the first time you choose it, the robot goes to a high position and then moves down until this sensor right here is activated. When that opens, because we're using the skip command, when this sensor opens, then it moves to its next line of command, which is to call the suction cup job. That's our pneumatic element. And the suction cup then is able to pick that up, and it runs the place job, which starts the conveyor. So after it runs the pick job and sets it down on the end of the conveyor, then the camera inspect job is called. And what it's looking for is it's going to check to see, is this the product that it's supposed to be? An initial problem that we had while we were teaching the camera program was that each one of these kinds of candy is so different from each other in size and in logo and in color. We couldn't find any common way for one program to identify which, even if there was a given product on there. So we had to write 4 different programs, and then as it runs the job, it looks to see, is it the job that it's supposed to be? They have to be stacked label up, because the label is the identifying factor for the given job. When it finishes the vision job, it passes a bit to the PLC to let it know that it has the correct product and that the robot and vision process is finished, and it passes it off to the PLC. Okay, we're ready to demonstrate. Okay.
So now you've seen what happens when we've here it identified it as Reese's. It's a positive match. It got like a 98% match on that. So go ahead and pass that. Turn one of those over, and we'll see what happens.
Okay. Which one do you want to do?
Let's reject the M&Ms.
Okay.
But that's our project.